Hi class, welcome to exercise 7c, sketching parabolas using factorisation. In our lesson today, we'll be doing example 6, where we're using the x-intercepts to find the turning point. And your pre-learning for this example is questions 1, 2 and 3 in the new book, and questions 5 and 7 in the old book. And then we'll do example 7, sketching a perfect square. And your pre-learning for this example is questions 5 and 6 in the new book, and questions 8 and 9 in the old book. And then finally, we'll do example 8, finding a turning point from a graph. And your pre-learning is questions 8 in the new book and question 11 in the old book. So this lesson will rely upon you knowing how to factorise by grouping and solving a quadratic equation. So they're important lessons in the previous blocks we've done in this unit. So if you're not super confident, make sure you go back and do them now, just to at least double check. Okay, for those of you who are ready, I'll see you in the introduction. So far in this block, we've explored parabolas and learnt how to find the key properties, the turning point, the dilation factor, and y-intercept. And so far the quadratic rule we've used has always been in the turning point form. In other words, y is equal to a times x minus h all squared plus k. However, quadratics are often in the form y is equal to a times x squared plus bx plus c. So how could we graph these? Alright, let's start by finding the y-intercept. And as always, that's just where x equals 0. So if we sub in 0 for x, we get y is equal to a times 0 squared plus b times 0 plus c, which is just equal to c. So that's pretty easy. The y-intercept is just c, which is the constant at the end of the equation. The next step is to find the x-intercepts, which is just where y equals 0, as is the case with any graph. So for y equal to x squared plus bx plus c, if y is equal to 0, then 0 is going to equal x squared plus bx plus c. And to find these zeros, just like we did in the quadratic part of this unit, we're going to factor and solve. And when we did that, we ended up with 0 is equal to x minus d times x minus e. And that's assuming that we have x squared plus bx plus c is equal to x minus d times x minus e. And by the null factor law, that means that x minus d is equal to 0 or x minus e is equal to 0. Therefore, x is equal to d or x is equal to e. So now we have a parabola with points c, d and e, where c is the y-intercept and d and e are the x-intercepts. For the quadratic rule, y is equal to x squared plus bx plus c, given that it factors to y is equal to x minus d times x minus e. So it's great that we found the x-intercepts for the first time, but what about the turning point? So next, we're going to have to find that turning point. So for this parabola, we're going to have to think about some key facts about the turning point, alright? Which I'll mark it on the graph, is on the axis of symmetry, which I'll also mark on the graph. And if we think about the axis of symmetry's key property, and that is if 2 points, which I'll mark it on the graph, are at the same height, which I'll also mark it on the graph, and both these points are on the parabola, then they are the same distance from the axis of symmetry. Let's call that distance f. Alright, so that's obviously badly drawn, that should be the same distance. So this means that if we have 2 points that are at y is equal to 0, then they are also the same distance from the axis of symmetry. So clearly the x-intercepts are at the same distance from the axis of symmetry, and let's just call that g. Now because the x-axis is just like a number line, if two numbers are the same distance from the same number, then that number is in the middle of those two numbers. And you should know by now that the middle of two numbers is the average of two numbers. So for example, here's a parabola with intercepts 1 and 5. So the average of 1 and 5 is 1 plus 5 divided by 2, which equals 6 on 2, which is 3. So that means that the axis of symmetry is x equals 3. Let's mark that in on the graph. So now we know the x value for the turning point, because that's the same as the axis of symmetry. So now all we need to do is plug this value of x into the rule and we'll find the y value. And hey presto, we have our turning point. But due to my lack of artistic skills, we really should check this out in GeoGebra, which you can go to by following this link. Okay, here's a replica of that problem I tried to draw. We have x-intercepts of 1 and 5, and sure enough, the axis of symmetry is x equals 3. Of course, it makes sense that it's 3, because 3 is in the middle of 1 and 5. Of course, the x-intercepts are not the only place this phenomenon exists. So if you have a look at the y-intercept, its y value is 5 and the x value is 0. This makes it a distance of 3 from the axis of symmetry. If we look at the other side of the parabola where the y value is 5, the x value here is 6, and that's also 3 away from 3, which is the axis of symmetry. So now that we know what the axis of symmetry is, we know that it is the x value of the turning point. So if we sub that x value into the equation, then we should get y of the turning point too. So you can see the equation y equals x squared minus 6x plus 5. So if we sub in 3 to there, we get 3 squared, which is 9, minus 6 times 3 is 18, so we've got minus 9, plus 5 gives us minus 4. And sure enough, our turning point has a y value of minus 4. So for those of you who are confident enough with your factoring, minus 1 times minus 5 equals 5, and minus 1 plus minus 5 makes 6. So you'll know that the rule we can see there factors to x minus 1 times x minus 5. Also, take note that the y-intercept is equal to 5, which is c. Now I'm going to turn on the segments that show the distance between the x-intercepts and the axis of symmetry. Changing the value of a moves the graph around, but notice the distance between both x-intercepts and the axis of symmetry are always equal. And let me change the value of b to 4 and c to 3 just to see a graph on the other side of the intercept. Another fact you can take away from the applet is that if a is equal to 1 and you can factor it by grouping, then the x-intercepts will always be whole numbers. If you can see a graph like this, and we can see that y is equal to 0 when x is 3 and when x is minus 1. And let me just zoom in for you there, so you can see the minus 3 value and the minus 1 value on the axis there. That means that this would factor to x plus 3 times x plus 1, because x plus 3 is 0 when x is minus 3, and x plus 1 is 0 when x is minus 1. Alright, let's go back to OneNote. Alright, as always, you can use that GeoGebra applet anytime you want, just follow the link. Anyhow, right now you should pause the video and work on some building understanding questions in the new book, which translates to questions 1, 2, 3 and 4 in the old book. I really think that before we start using the full concept in all the examples, it's really helpful to practice each skill, and that's what you'll do at this stage. Anyhow, we'll see you in the next section. So when given a rule, y equals x squared plus bx plus c, the method for finding the turning point with the x-intercepts is 1. Factor the quadratic. 2. Find the x-intercepts, in other words, where y is equal to 0. 3. Find the y-intercept, which is where x equals 0. 4. Find the axis of symmetry, and this is the average of the x-intercepts. i.e., if the x-intercepts are a and b, then the axis of symmetry is where x is equal to a plus b divided by 2. And then finally, step 5 is finding the turning point. And the way we do that is plugging the axis of symmetry into the quadratic rule to find the y value of the turning point. And then when we've done all that, we can use the intercepts and the turning point to draw the parabola. Alright, let's put this method to use in example 6, where we're going to have to sketch the following. In part A, we have y is equal to x squared minus 2x, which I can factor to y equals x times x minus 2. And we'll draw that on these axes. But before we get onto the drawing, let's point out that we have two factors with an x here. We've got this x and this x minus 2. So when y is equal to 0, x is equal to 0 or x is equal to 2. So let's mark those in on the graph. And the average of 0 and 2 is 1, but I'll just do 0 plus 2 on 2 equals 1, just in case someone's reading this later on and wants to know how I got there. And now we know that, we can sub the 1 into the rule and we'll get y is equal to 1 squared minus 2 times 1, which is equal to minus 1. So we've got an x value of 1 and a y value of minus 1. So let's mark in our turning point. And it probably doesn't need to be mentioned, but you can see that the y-intercept is definitely 0 there. So we have all the information we need to draw a parabola. It's just a matter of how bad my artistic skills are here. Close enough. All right, let's move on to part B, where the quadratic rule is y is equal to x squared minus 6x plus 5. And we've already seen this, right? So we know that y is going to factor into x minus 1 times x minus 5. Okay, so minus 1 times minus 5 is plus 5, and minus 1 minus 5 is minus 6. So if you expanded this with FOIL, you would definitely go from the bottom to the top. So by the null factor law, when y is 0, x is either 1 or x is equal to 5. So because they're our x-intercepts, our axis of symmetry has to be 1 plus 5 on 2, which equals 6 on 2, which is 3. And we already did this in the applet, but we should do it formally here anyhow. If x is equal to 3, then we sub that in for y is equal to 3 squared minus 6 times 3 plus 5, which you know is equal to minus 4. And because c was equal to 5, we also know that the y-intercept is 5. But you could also look at even our factorisation one up here, and if x was 0, we would get 0 minus 1 times 0 minus 5, which is minus 1 times minus 5, which is 5. All right, let's graph that on these axes here. So we have x-intercepts of 1 and 5. We have a turning point of 3 and minus 4. And we had a y-intercept of 5. Let's mark that in. Okay, this is going to be a super test on my artistic skills. Let's start with the left-hand side. Close enough. Let's go the right-hand side. All right, fantastic. We can see that axis of symmetry there, where x is equal to 3. I think you'll have no trouble with these at all. Maybe a bit of fiddling around to start with, but once you get into it, it'll be fine. But let's test that out by pausing the video now and doing questions 1, 2, and 3 in the new book and questions 5 and 7 in the old book. And then we'll see you in the next section. When a quadratic is a perfect square, such as y is equal to x plus b squared, then there's only one x-intercept, and that's where x is equal to minus b. This intercept is also the turning point. The y-intercept is always where x is equal to 0, so subbing that in, that means we got y is equal to 0 plus b squared, which is just b squared. Okay, so let's get straight into example 7, where we're going to sketch y is equal to x squared plus 6x plus 9. Now all our factoring fun is given away because we know this is a perfect square, but also you should know that we've got 3 squared for 9 and 2 times 3 for 6. So in this case, y is going to equal x plus 3 all squared. And the turning point and the x-intercept is minus 3, 0. And our y-intercept is where x equals 0. So 0 plus 3 squared is 9. You should also notice that 9 is c in this rule, so that gives it away as well. Let me paste in some axes here, and we'll draw this graph on that. So here's minus 3, which is going to be the turning point and the axis of symmetry. And our y-intercept is 9. So we can draw the right-hand side of the equation. Alright, and now the left-hand side. Close enough. Well, I think this will be one of the easiest sections you do this year, so let's pause the video now and do questions 5 and 6 in the new book and 8 and 9 in the old book. Hopefully you'll notice that perfect squares always sit on the axis, okay? Always sit on the x-axis. That's positive and negative. All right, we'll see you in the next section. For a parabola to have x-intercepts E and F, it means that y is equal to 0 when x is equal to E and x is equal to F. So in other words, x minus E is equal to 0 and x minus F is equal to 0. So therefore our rule must be y is equal to A times x minus E times x minus F. And that's just by the null factor law. Now if you know what A is, you can figure out y equal to A times x squared plus bx plus c. And for the questions that you do in your exercise, if nothing's said about A, you can assume that A is equal to 1. And then we still need to find the turning point. And we know that has an x value that comes from the axis of symmetry. And as we've covered in all the other sections, if we had y was equal to x minus E times x minus F, our axis of symmetry is x is equal to E plus F divided by 2, which is just the average of E and F, right? So now that we've got the x value of the turning point, all we need to do is sub this x value into the rule to find the y value. Let's have a go at this with the example 8. But we're going to find the rule from a graph like this that has x-intercepts minus 3 and 1. And I better draw the actual parabola. Goodness me. So let's try and figure out what this turning point is. Alright, so as we were saying before, if y is equal to 0, then x is equal to minus 3 and 1 here. So we're not told anything about a, so let's just say we're assuming a is equal to 1. We know that the rule will be y is equal to x plus 3 times x minus 1. And that's because if x is 1, x minus 1 is 0, or if x is minus 3, x plus 3 is 0. So the axis of symmetry is the average of those numbers. And those numbers, of course, I'm saying the x-intercepts. So minus 3 plus 1 on 2 is the average of minus 3 and 1. And that's equal to minus 2 on 2, which is equal to minus 1. So we know that our turning point has an x value of minus 1. And when x is equal to minus 1, then y is equal to minus 1 plus 3 times minus 1 minus 1. And that's just by subbing minus 1 in for x. So minus 1 plus 3 is 2, and minus 1 is minus 2. So we end up with 2 times minus 2, which is minus 4. So our turning point has an x value of minus 1 and a y value of minus 4. And we should really mark that in on the graph, eh? All right, so that's it for that one. When a is equal to 1, they are that straightforward. But of course, it might get a little bit trickier when it's not. And let's make a note about that. For y equal to a times x minus e times x minus f, the x-intercepts will give you the e and f, right? But you're going to need a third point to work out a using the techniques that we learned in the last lesson. So that's why I say just assume a is equal to 1 unless you're given a third point. Anyhow, this is something you can see in the enrichment section of this exercise. Anyhow, right about now, you should pause that video and do questions 8 in the new book and question 11 in the old book. And then come back for a summary, which will also have a mini challenge, and look at the way we could have a different a but the same intercepts. Alright, I'll see you in that summary. Okay, at this stage, you should be able to see the point of factoring by now. Many real problems are solved with quadratics and parabolas. And we've seen some of these applications in the quadratics block, but you're going to be seeing more of these in the next block. Speaking of which, this is the end of this block, so make sure that you've mastered all these concepts. And as you explore these parabolas, it might be a good idea to use all of these applets I've created, which you can find the link for here in the OneNotes. And speaking of which, I'd like to explore something with this GeoGebra applet right now. Now I know it's not a normal thing to do in the summary, but it is a summarising skill in lots of ways. Now, following on from what we did in the last section, let me type in a is equal to 1, which is already there, and b equals 2 and c equals minus 3. So you can see that this gives us the intercepts minus 3 and 1, And our turning point is -1, -4, just like in our answer. Also, notice that the y-intercept is -3. And our equation says x squared plus 2x minus 3. Now let me double every value there. That means a is 2, b is 4, and c is -6. And following this, we've now got exactly the same axis of symmetry and the same x-intercepts. But our y-intercept is now 6, and our turning point is -1, which is still the same, but -8. So our turning point was relying on the fact that a was equal to 1. So you can see this is a different equation here. Y is equal to 2x plus 4x minus 6. So as you work through these, unless stated otherwise, a is equal to 1. But if you see a third point there on that graph, you need to check if a is equal to 1. All right, let's go back to the OneNote. All right, so in this lesson, a successful student will know the steps for sketching a quadratic graph in the form of y equals x squared plus bx plus c. Understand that quadratic graphs can have 0, 1, or 2 x-intercepts. Know how to use factorisation to determine the x-intercepts of a graph. And know how to use symmetry to locate the turning point once the x-intercepts are known. Okay, so they're all the keys to success. But before we go, I do want to bring back a mini challenge. Okay, so here is the challenge. So if we got a rule where y is equal to a times x minus e times x minus f, I want you to use your amazing algebra skills to show me that the turning point is e plus f on 2 for the x value and minus a on 4 multiplied by e minus f all squared for the y value. Okay, so that's a little point there. All right, good luck. I hope you can do that. I'll be super impressed. Either way, keep working hard. Make sure you get all the key skills down. We'll see you in the next lesson. Bye.